This circuit is called a JK flip-flop. Really, it's just one bit of computer memory just like the SR latch, and it works in a very similar way, except it has one additional state that the SR latch did not have. And let's just run through it. So in this case, instead of having the clock go to a little timer that went up and down, a little oscillator, my clock, I just made it a switch so I can flip it up and down and we can see exactly what's going on. And don't get freaked out by how complicated the circuit looks. Really, you just have to understand for any given input what the output will be. So in this particular case, I now have J and K, and I don't know why they called these switches J and K for a JK flip-flop. They just named them J and K and call the thing a JK flip-flop. No particular reason. So I'm right now in memory state, and if I run the thing, you can see that I can flip the clock up and down and no change occurs, right? Q and not Q have not changed. If I want to set this memory, I flip up switch J. J is my set, so this is a 1 now. And if I clock this up and down, you can see that I have now set Q to a 1. I can go back to memory state, and if I clock up and down, no change occurs, right? It remembers the state that it was in previously. I can reset my JK flip-flop by putting K to a 1, setting K to a 1. And if I clock this up and down, and if you notice real carefully here, if you look closely, you can see that things happen when the clock goes from a 1 to a 0. That's called a negative edge flip-flop. Things happen on the negative edge of the clock. Now I'll go back to memory state. I'm in memory state. So again, just like the SR latch, I can set. In this case, I'm using the J to set. I can reset using K, and I have memory state. There's one additional state, and that's why all this extra logic is here. And that additional state is called a toggle mode. If I flip J and K both to 1s, every time the clock goes down, my output alternates. You can see that Q is either 1 or 0, and it alternates every time the clock goes down. And of course, not Q is always the opposite of Q. So your JK flip-flop has a set if you flip J to 1. It has a reset if you flip K to 1. It has a memory state if J and K are both 0s. And it has a toggle state. Toggle means it flips back and forth between 1 and 0 if both J and K are 1s. And again, things only happen when the clock goes. In this particular case, things only happen when the clock goes from 1 to 0. But you can set up the logic so that things happen when the clock goes up or down or at a level state. A little bit more about that later.